Today we will be learning about your virtualization, your different container, your Dockers, your Kubernetes, right? We'll talk about what are the different platforms for these technologies. And if we get some time, we will start with the basics of Azure. That we will see the Azure portal, what all things are there, what all resources we can get through your Azure cloud, right? So this will be the today's agenda, right, to discuss these things. So let's begin, right? So in your container technologies, we'll be talking about your virtualization. What is virtualization? What is virtual machine? Then what is a container, right? Because whenever we talk about cloud, we talk about your containers. Then in your containers, we have different platforms. We have your Dockers, we have your Kubernetes, right? We will talk about your microservices. So basically today we'll be talking about container as a service in your cloud and function as a service, which is your serverless function. And we will see what is your Azure portal, what all resources we can see in your Azure portal, how we can use that thing, how we can get a subscription of Azure, right? Is it free or not, right? All these things we will discuss today, right? So starting with your virtual machines and containers, right? So before this particular thing, whenever we talk about your cloud, we have a concept which is your virtualization, right? So what virtualization is, it is your ability to run multiple operating systems in a single physical device, right? So because of this particular thing, I can run multiple operating systems in my own device, right? So right now I'm running Windows, right? You all can see. But with this particular technology, it will allow me to run more than one operating system, right? So we have different virtual applications, right, from different vendors. Once we download that particular thing in our system, what that will do, that will divide allow me to divide my hardware resources, right? So these are nothing but your virtual machine, right? This thing happens with the help of your hypervisor, right? So if I show you one virtual machine for your Windows, I'm using VMware, right? So it's an application which is from your vendor VMware. Because of this particular application, right? So this application is based on the technology of virtualization, right? Because of this particular application, I can run multiple operating systems, right? So at the left, you guys can see I can run multiple operating systems using my hardware resources, right? Using the resources of this particular machine, I can run all these machines at a single time, right? So we think of this. If I talk about an example that how we can remember this thing, right? You purchased a notebook for this particular webinar, right? So that notebook is having like around 100 pages, and at the end of this webinar you were able to consume only 10 to 15 pages, right? So your 80 to 75 pages are still remaining, right? So how you can utilize this particular thing with the help of a hypervisor, and in this particular practical example, we can call that hypervisor as your bookmark. Okay, so with the help of your bookmark, you can utilize the remaining pages, right? Same thing here. Right now I'm using my Windows machine, right? So there are some applications which are not able to run on Windows, that will only run either in your Linux or some other operating systems, right? So with the help of this particular application, your VMware, I can utilize the remaining resources of my system, right? I can divide the resources, and that particular thing will never affect my main operating system, right? Your hypervisor separates your operating system, your main host operating system, from your virtual operating system, right? So remember this thing whenever we talk about your virtual machines. Your hypervisor will be placed between your hardware and your main host operating system so that you can run multiple operating systems at a single time, right? So here in this particular thing, in your infrastructure, I will have my RAM, right? I will have my hard disk space, right? And like this, I can divide multiple things. I can create a new network also. This thing will have some of the RAM, like my operating system, my Windows is consuming only 2 GB of RAM and let's just say around 100 GB of hard disk space out of 1 TB, right? The remaining is if I am having a RAM of around 8 GB, the remaining left is the wastage RAM is around 6 GB, right? So what I can do with the help of this particular application, your VMware, I can utilize this particular 6 GB to run different operating systems, right? It can be your Linux, it can be even your Windows, no problem with that. I can run two Windows with this particular application. It can be your iOS, right? It can be some other machine also, right? These things can happen with the help of this particular technology. Now comes the part that what actually is your container, right? So here we are talking with respect to your physical machine. We are sharing the resources of your physical machine. Now how this thing, like if we are shifting towards cloud, right, we cannot use this thing, right, because we don't have any physical machine, right? We are using the machine of your cloud service provider, right? So what we can do in your container, so if I define what your container is, it is a package of application or software, right? Here we are talking in terms of your operating system. Here we will be talking in terms of your application or a software, application or a software. So what we will do, we will put all your bin files, your library file, your configuration files, right? All the other resources which will be needing to run this particular application or a software at a single place, right? So that whenever someone wants to run this particular application, he can call this particular thing. He can call this particular thing. So with this thing, all your files and resources which will be there to run this particular thing comes along, right? How this thing will help me? It will save my space. The major problem which we face today and which is getting very costly is your space, right? So that in different virtual machines, right, if I'm using 4 machines, I don't have to save this particular resource file in each of the file, right? I can simply save this file in a server which is called your container server, and anytime when I want to run this particular application on any of the machine, I can simply call this container server and I can ask for this particular image of the application, right? So that it will save the space on each of these particular device, right? Now you will say that okay, since here we are talking in terms of operating system and here we are talking in terms of your application or software, right? So whenever we create a think of this particular thing, right, if I talk about this term, let's relate this to this particular real-time example, right? So whenever you go for an interview, right, you have a, yep, what is the difference between VMware and container? Yep, I'm explaining that only, right? So whenever you go for an interview, you have a folder with you, right? In this particular folder, you will have your CV, you will have your documents, you will have your certificates, right? All the things which you need, right? So right now we are like 40 people around. We all went for a particular job. The job description is your cloud security engineer. We all are going to this particular company, right? This is your company. We all are going for this particular role, your cloud security engineer. With this particular document, right? This particular packet will have all your CV, your necessary documents, your certifications, right? Which the individual might want to see, right? You went with this particular thing to this particular company, right? Now we all 40 people went there. The company will select that which is the best person, which person is having the best package, and according to that it will select and it will use that particular thing, right? So your package is nothing but your application or your software. Okay, your packet is nothing but your application or your software. It is containing all the necessary resources to run this particular thing, right? Now this company can be any company, right? If let's just say I for now right now want to use a particular application and I don't have that much space to save this particular thing, what I will do, I will call this particular container image of the application, right? So the difference between your virtual machines and container is this thing uses your resources, your infrastructure resources, and you don't have to set any operating system, right? Your hypervisor is placed right above your operating system, right? So that your main host operating system and the operating system, your guest operating system, does not get involved with each other, right? There will be always a separate line, a thin line between them, right? But if I talk about your containers, right, these things will already have your operating system image, or your, we can say, your kernel files in this particular path, right? Your kernel files will already be there, right? So that if this operating system is Windows, I can only call the applications in this particular container server which is having Windows kernel files, right? So we create different container image for different operating systems, right? So if I'm using Kali Linux, let's just say this is my particular application. This I will create three images for this particular application. One for your Kali, one for your Windows, one for your iOS. Okay. So if a person, if you want to use this application in your Windows machine, you call this particular thing. If you want to use this particular application on your iOS, you can call this particular thing. If you want to use this for your Kali Linux, you can call this particular thing, right? So here, when we create a container image, your kernel file will already be included in that particular image, right? You don't have to give your operating system at that particular time. But in case of your VMware, your hypervisor will divide, or we can say it will create a thin line between your main operating system so that you can run multiple operating systems, right? So when we talk about virtual machines, we talk about your operating systems. When we talk about your containers, we talk about your mostly applications or your software, right? Now comes one main thing, right? If I create a container image, yeah, yesterday we talked about like creating your Tinder, right? We discussed that how we can create your Tinder application, right? So today we will pursue with that example only, that okay, I created a Tinder application, right? This is my Tinder. It will have all the necessary resource files to run this particular application. Now the main problem comes, each operating system works on some different bin files, right? So I have to make sure that when I'm trying to create this particular Tinder application, it should be having a kernel file for your Windows so that it can run on your Windows. It should be having a kernel file for your Linux or your Kali so that it can run on this particular operating system, and it should have like any other operating system we have, it should have that kernel file also, right? So I created this particular Tinder application for the Windows, right? And you like any user who is using your Linux or iOS, he says that this application is not running for me. This application is not running for me. So I will say why it is running on my machine, it should run on your machine, right? At that time, the developer is not aware that he created or he used the kernel files of the Windows machine. That is why it is not running on your Linux environment, right? So to solve this particular problem, we created your Dockers. We created your Docker. So this is your open source technology, which is again used for developing, packaging, and running application and all its dependencies, or you can say your necessary resources in the form of containers to ensure that the application works in a seamless environment. Okay, so what can happen, these three images which I created for different operating system, I will store them in a I will store all these three images in a Docker platform, right? So this is image 1, this is image 2, this is image 3, right? So if any user who is using your iOS, he can simply call this particular image, right? So that it will not have to download these particular two image also, right? So this particular Docker, what it basically does, the job is same. The job is to make your container images, but it will make your environment very seamlessly, right? It will make it very smooth so that the user does not face any problem while using that particular container image, right? Simple thing. You are right. I am right now in my Windows, and someone is using like from this particular session your Linux. Both are very different operating systems. Both will have some tools which will run on some Linux and some on Windows, right? Chances are there that tools running on Linux might not run on Windows, and tools running on Windows might not run on Linux because of the dependency files. Both operating systems have different things, right? So there is one this particular application which I created as a developer, right? I created this application, and I created two images, two container images of this particular application in your Docker platform. One is for your Windows, one is for your Linux, right? One is for your Windows, one is for your Linux. Now someone comes to me and say that, yes, I want to use this application. I want to use your application. I will say, go to this Docker platform, download the image according to your operating system, right? So if that particular person is using Windows, he will download this particular thing. If he is using Linux, he will download this particular thing. Like this, I will create multiple images for different operating systems so that no person face any problem while using this particular application or your software, right? So when we talk about your Docker, we don't use the words. So the each image will be in separate containers. Yep. Each image will have, see, when I talked about containers, right? I told you that when we create a container image, it will already have the kernel files here. In your containers, we include your kernel files. Okay. So it is for a particular operating system. Any container image will be always for a particular operating system, right? It will not be used for all the operating systems. Okay. So same things when I create two here I created two container images, one for Windows, one for Linux, right? Now we don't use the terms download and right all these things in your Docker. We use your pull, run, and build. When we talk about your Docker architecture, we use the term build, pull, run. If I'm a developer, what I can do, I can build image. If I want to use some container image from your Docker architects, I will pull that particular thing. Then after pulling into my system, I will run that particular thing through this server only, right? So that I can save space in my operating system, right? So we use these three terms: build, pull, and run. Build is to build some container image which you want. Pull, we will request for a container image. Once we pull all the necessary files, your dependencies, and your different resources for that particular image, we can simply run that particular thing, right? So here you can see that this is your Docker host. This is the name of that particular host. These are the containers, and these containers have different images of different softwares or applications, right? Registry: whenever you create a Docker platform, for sure you have to register yourself at that particular place, right? It can be any vendor, any well-known vendor. You have to register there. Through that, only once you register there, you can build your own application, you can build your own container image there. Okay, so this is your Docker, right? So difference between your Docker and container, I will say Docker makes sure, right? So if I talk about the difference between your containers and your Docker, containers at that particular thing we create for different operating system, right? And in your Docker, what we do, we add all the images for different operating system, so that users can like easily use the application without facing any problem. Basic example: I am playing a game, okay, I'm playing some game, and someone like one of my friend asked that, okay, yes, this game looks very cool, please share it with me, right? My machine is Windows 1, my machine is Windows 1, right? His using your iOS, is using your iOS. Okay. So he saw some game which I was playing on my machine, and he said that this game looks very cool. Like, why don't you share this particular application image with me? Right. So what I did, I encrypted like all this particular game, and I transferred this to him over some Google Drive. Okay. He downloaded this particular, he extracted this particular thing, right? And he tried to install it over his machine. He tried to install or run this particular image over his machine, but this game was not running on his machine, right? This game was not running on his machine, right? Why? Because the game's image was built on Windows operating, right? It was built for your Windows. That is why it was not able to run on your iOS, right? Now what we can do, instead of like sharing my file, what I will tell him, okay, I downloaded it from this particular website, okay, I downloaded it from this particular website. You will see the option that download for Windows, download for iOS, right? Go and click for download from iOS, right? So now I'm making sure that he is downloading the file which is for your iOS, right? Same goes for Docker only. It will have different container images for a single application only, but each image will be for different operating system, so that the user does not face any problem while using that particular application, right? Same thing for your Tinder application. You can relate your example also. While if I'm trying to create an application, I will want that this application is accessible to each and every user, irrespective of the operating system that they are using, right? So I will make sure that I have multiple images for this particular application for all the operating system. Okay. Then we have microservices, right? Simple example: you are using Facebook, like most of the people might be using Facebook. Facebook have a front end, right, which we are able to see. It will have a front end, it will have a back end for the developers who are managing this particular website. It will have a back end, it will have a database, right? It will have a database to store all our username and password, all of our information which we are giving to Facebook. It will have a database, right? For sure, we can say that like this, it will have n number of things, right? Like this, it will have n number of things. What these things are, these are your services. This is for your front end user, this particular service. This is for your back end user. This is for the people who are managing your database. Like this, we will have multiple services. Now, you cannot like work on each and every service at a single time, right? If I create this particular thing or this application, and in this application only I'm working on front end, working on back end, working on database, right? it becomes very hectic and very messy, right? So it becomes very unstable to manage this particular thing, right? So what we do, we divide this application into different parts, right? I will divide this particular application into different parts. One will be for the people who are managing my front end, one will be for the back end people, one will be for the people who are managing the database, one will be for the management team who is managing all these things, right? Like this, I will divide the different services and I will create a separate container for them. Right. This front end will have a separate container. This will have a separate container image. This will have some separate container image. Right. Like this, at the end, when the user want to use this particular thing, he can call this particular thing. Right. So that my works become a bit less messy to manage all these things, right? So during your applications, what we do, we create different teams, right? One will be making sure that the database is secure and database is stable. One will make sure that your user interface is very good. One will make sure that everything is working at the back end, right? Like this, we have different teams, right? So when this particular thing works at a single time, right? All of these things are working continuously with each other at a single time. It makes your microservices, right? So if you are dividing your application into your different parts so that it can be very easy to use, right? And it will be very easy to work upon, that particular application become your microservice application, right? These things work with each other, we can say, in a circle, so that a front end is requesting for some database, this will directly work with here. Your backend will directly work with here. Your backend can work with your front end, like this. This is working in a complete circle. So in this particular example, like in this particular image, you can see we can say this is for your database, right? If I talk about a particular application, this is your front end, like people who are managing your front end, your front end developers, your back end developers, right? Like this, they created a different image for themselves. And what user is accessing, it is accessing all these particular images at a single time, right? All the images are being accessed by a user at a single time. These are your microservice. I'm dividing my application into different services so that it will become very easy to manage at the developers end. Okay. Then we have container orchestration, right? So right now we discussed what container is, right? So it is nothing but your application or software package which have all the dependency files and resources needed for that particular application, right? Right. It is your automated process. It will manage the life cycle of your software containers and their dynamic environments, right? So the job of your container orchestration platforms, right? We have different platforms for this to manage the life cycle of your software containers which we created and with respect to their dynamic environments, right? So if I'm using 5 containers at a single time, right? So of course, with the help of this particular platform, I can manage them, I can schedule them, right? I can distribute them according to their workloads, right? If right now a user requested for your database, I can distribute that particular database to the user, right? If the user requested for some other service which I was offering with that particular container, right, I can send that too, right? So we manage all these things with your container orchestration, right? The most famous platform which we have for this is your Kubernetes, right? So you can see the automated task which it automatically does is your scaling, your provisioning, your deployment, your configuration, your availability, security, health monitoring of that particular image, your load balancing, your resource allocations, right? These are the things which are automatically done with this particular container orchestration, right? So we have these particular orchestration software, your Docker Swarm, OpenShift, your Kubernetes, right? Through these particular softwares, we manage all these tasks in a particular container. So application environment with multiple containers, we will manage how we will manage different containers with this container orchestration. Okay. Now comes the question that why, what is Kubernetes and why do we need them, right? So as I said, your Kubernetes is nothing but your container orchestration software or a platform which will help me to automate the task according to that particular image, right? For example, right, if see the first difference between your Docker, like first we talk about your Docker. What Docker is, it is used to build, deploy and run containerized applications on a single operating system, right? So with the help of Docker, I can build or run any containerized application in different operating system, right? This is one job for your Docker. But sometimes you need someone to manage this particular thing also, right? So to manage this particular thing, Google created your Kubernetes, right? In 2000 around 10, right? In 2010, Google created your Kubernetes. So there are like multiple, we use your Docker to build, run and deploy, right? Main functioning of your on a particular operating system, right? On a particular operating system. Job of your Kubernetes is to scale, update, manage. We can also say we can delete or destroy, right? The particular container, right? So if I'm using right now 4 container images, right, through this particular Docker, but my application got a hit. Again, we talk about Tinder. My application got hit. Now, out of 100 people, all of a sudden, in just 1 hour, 1 lakh, 100,000 people started using this particular application, right? So I have to scale this particular thing, my image, so that my app don't get crashed, right? So what I will do, I will manage all these things with this particular platform, which is your Kubernetes, right? What I will do, this platform, what will do, it will automatically build me. This particular thing is acting as your manager. He will manage each and everything that is happening over your container image. A Kubernetes basically act as your manager, right? He will manage each and thing if necessary. If he wants to add 4 new members in your team, he will like call your HR and he will say that okay, we need 4 new members in the team. If he wants to like remove some employees from that particular team, he can do that. If he want to give a promotion to a particular person, he can do that, right? So your Kubernetes platform is nothing but your management platform, right, where you will be managing all your container images from scaling to updating, right, from destroying and management. All that part comes from this particular single platform, right? Now to sum up all these things in a single example, right, very simple example, so that you guys can like understand or remember this thing at a very long time, right? This is one company, right? This is some company named X, right? They called for people, they are interviewing for your cloud security engineers. We all are 40, around 40 people, right? We all have a packet which have our CV, your documents, and we can say your certifications, right? Different resources. These things, let's call them your containers. Each person will have a different container image. Okay. Now we are applying for this particular job role. It means each image, right? Each of this particular container image is for a single operating system, which is for your cloud security engineering job. Okay, so we all are applying for this particular operating system. We have different images. Now we all went for the particular interview with our images. Who will manage this particular thing? Your interviewer is nothing but your Kubernetes. First, before this particular thing, when we apply at that particular portal, we will save all our images, right? We will send our CVs at a portal. That portal is nothing but your Docker. That portal is nothing but your Docker. We first send our CVs. If we get shortlisted, your Kubernetes will manage this particular Docker image. If you get shortlisted, they will call you for your interviews based on your container image. And if you got selected, they will use your container image. They will hire you as an employee, right? So if, like, again, if you are applying for some different job role at some different company, your operating system will change. If this thing is changing, your container image will change. Okay, so this container image is always for a particular operating system because it will have a pre-built title which is for your cloud security engineer, right? You are applying, you are creating a CV for your cloud security engineer. Okay, so where we put this container image, we are around 40 people, so we will put 40 images at your platform, your career site, which is your Docker. If we get shortlisted, who will manage this particular portal site? Your interviewer, who is your Kubernetes, right? He can manage, like, he will scale. He will see that if your CV is okay, very good, he will select you. If he finds that okay, this person is not suitable, he will delete that particular CV, or he will not mail you back for your interview. He will not schedule your interview, right? Like this, management part is done by this particular person. Your storing part is done by this particular person. We all are applying for this particular company. We can say this is your infrastructure, and the operating system, your job title is your cloud security engineer, right? So through this particular example, you can get what is a container, what is a Docker, what is a Kubernetes, what is your operating system, what is your infrastructure, right? Like this only, right? So that you guys can, like, remember for a very long time. Now comes the part that what are different container management platforms, right? First, we have your Docker, which we already discussed. Other than your Docker, with your cloud service providers, for your Amazon, we have your Elastic Container Service, your ECS. For your Azure, we have your Azure Container Instance. Okay, for we have your Portnair, your Rancher, your OpenHat, OpenShift container platform, right? So you can use these particular platforms at your organization also, right? So mostly, like, people are using this particular thing, or Docker, very famous. Okay, then we have your Kubernetes platform also to manage all your different container platforms. Okay, so you can see that Kubernetes is an open source container orchestration engine for automating deployment, scaling, and management of containerized applications, right? So this particular platform manages your container application. Okay, so we have your Kubernetes itself. We for with your AWS, we have your Elastic Kubernetes service. We have your Docker Kubernetes service, Knative, IBM Cloud Kubernetes service, Google Kubernetes engine, right? Google came up with this particular thing, your Kubernetes. Google was the first vendor who came up with this particular platform, your Kubernetes. Okay. Now this is for your Google Cloud, Google Kubernetes engine, right? If you are using your Google Cloud, you can, like, simply see there is one. engine, which is for your Kubernetes itself. Okay. Now, yesterday, like someone asked what your serverless computing is. It allows to build and run application without thinking about servers, right? So, right, I'm like again learn. Let's learn it with an example. This is me, the manager, right? I'm managing five machines under me. Okay, I'm managing five machines under me. All of this is happening over a cloud, right? All of this particular functionality is happening over a cloud. So I'm managing five machines under me, right? Now, since we talk in your cloud, we talked about pay as you go. So I only pay for the services that I use. Okay. I want to use something, I want to create something that if one of this particular machine stops working, right? It can be due to any technical problem, right? Any problem it can be. If one of this particular application stops working, I should get a mail, right? So what I did, I called my developer. Okay, so here's the thing. I need you to build a application or software for me. And what that application will do, if this system stops working or if this particular system gets disconnected from my particular machine from the main server, I should get a notification or a email that this particular machine is not working or is disconnected from the main server, right? So this was the job of the developer. What he did, he wrote some code, he wrote some line of codes, he created some functions, and he created this particular application. Right, he created this particular application. That okay, yes, I created this application. Install this application on each and every device. Right, and this application will make sure that this particular device is connected to your server. Okay, this device is connected to your server. If it's get disconnected, you will get a notification at at your email that okay, this particular machine, your machine number one, is not working or is disconnected, right? So this is the process, right? But since I am using the cloud, so when we talk about cloud, we always talk about cost, right? I want to save, of course, my cost. So what I will do, I will build a function at your cloud platform, right? I will build this particular application over your cloud platform, right? Using your different platforms have different serverless computing functions, right? So since we are talking about your Azure, we will use your Azure functions, right? So what will happen over this, I will write a code, and the code will be that if any of this machine stops running from my main server, send me a mail, right? Now the advantage of this particular thing is, since my machine is like always working 24/7, but only at a particular time it will stop, I will only pay for that particular time only, right? I will not pay for 24/7 because this machine is running 24/7. I will not pay for this particular thing. I will only pay when this particular function is used. When it will be used, when this machine will go offline, when I will get a mail. I will only pay for that 1 or 2 minutes when this function come into that particular act. Right. So this is where you use your serverless computing, right? Allow to build and run application without thinking of servers, automatically provisions, scales, and manages, maintain the infrastructure required to run the code, right? It does not care about your servers, that what operating system you are running, right? It will automatically come into the action. Just like yesterday, I explained you guys with that particular example that when you get the option in your Windows update that if you're not, you can set a timer, right? So at that particular timer, your update will automatically take place, right? So we can say it is like a triggered bomb. Whatever time, whatever place, like whatever date we set, it will work on that particular thing only, right? Whenever it will be triggered, this particular function or the particular application which we created in this, whenever that particular thing will be triggered, at that particular time only it will work, right? So I can create an application or I can create a function that after 4 days, every device should get the mail, right? I'm running this particular 5 devices in a cycle, right? So after 4 days, every device should get a email that okay, your you need to take rest, right? So you have a off day, right? Like this I can set some application for that particular thing, right? So on fourth day this particular device is receiving that particular email. On fifth day, on the next day, this particular thing is receiving. On this next day this particular device is receiving that, right? Like this all this particular function is running in a cycle. We are using the resources only when we need it. Okay, we are not running those resources 24/7. We are only needing the resources, we are only using those particular resources when we need that particular thing, right? So right now, like very simple example, right now you need your internet to attend this particular session, right? But after the session the chances is there that you don't need the internet. When you are like having your lunch, you don't need your internet, right? So if we can, what we will do, we will create a function something like this, that okay, my mobile should run this particular internet when I'm attending this particular session, right? At 9 p.m. I'm having my lunch or my dinner, right? At 9 I'm having my lunch or dinner, right? So my internet should automatically be turned off, right? I created a function, right? So this function will only become into act when I need this particular resource, right? I will set the rules. It will be me who will be setting the rules that when I need to run this particular function. Okay. So again, the difference comes what is your serverless and what is your container. So here the developer is responsible for defining container configuration files along with operating system, software, library, storage, and networking. Right? All the things will be maintained by your developer in your container. But when we talk about your serverless computing, it will be taken care by your cloud service provider. Okay. So you are using the functions which are created by your CSV. Okay. The job of the developer is to simply upload or deploy that particular code over the particular cloud that you are using. Okay, it will run, the container will run 24/7 once you deploy this particular thing, but this is on demand thing, right? It will only run when you call for this particular function, and once the job of this particular function is finished, it will automatically destroy itself so that cost can be saved, right? Very simple thing, we are talking about cost, right? That is why we shifted to your cloud, right? So it will automatically destroy itself once the job of this particular function is finished. A container needs server support even when the container is not executing in any programs, but in case of your serverless computing, no server support is needed, right? It will only charge for your resource consumption, right? At what particular time you are using that particular function, it will charge for that particular time only. Timeout is enabled on serverless functions. There is no time restriction for the code running inside the container, because when we talk about your serverless, again same thing, only called when you need. Once the job is over, you will it will automatically get deleted itself, right? Serverless functions are suitable for microservices application. Why? Because at one particular time, chances are you call for database At one particular time, you call for search option. At one particular time, you call for login option, right? So once the job of this particular function, your login code is over, it will automatically get deleted from your microservice, right? So that other processes can run bit faster, right? That is the main thing, right? So we basically use your serverless functions when we create your microservices application. Okay. Best example again, I tell you your Gmail and Google Calendar. Whenever you receive a email, your invitation email, you will see that it is automatically marked over your Google Calendar, right? So Google over that particular cloud has created a function that if someone is sending an invite email to your Gmail, it should be automatically marked over your calendar so that you don't miss that particular thing, right? Best example to think of your serverless computing. If you are not receiving any invitation email, this function will not respond. But as soon as it has been marked over your calendar, the job of this particular function is completed and it will automatically destroy itself. Okay. We have different frameworks for Microsoft Azure. We have your Azure functions, right? We have your AWS Lambda for your AWS, Google Cloud Functions, IBM Cloud Functions, AWS Fargate, Alibaba Cloud Function Compute, right? These are different serverless computing frameworks for different cloud service providers. Okay, so this was all about your container technology, right? We discussed your containers, your virtualization, your VMwares, your microservices, Dockers, Kubernetes, serverless computing, right? So let's just say like we have our own infrastructure at your Azure. Okay, we are using your Azure cloud. We have our own infrastructure over there, right? I'm the admin. I'm managing all the machines that is running over my Azure cloud. Okay, I'm managing all this particular application that is running over my Azure cloud. Using this particular Microsoft Azure functions, right? What I will do, I will write a piece of code, right? And in this particular piece of code, I will write something that, okay, anytime when someone makes a HTTP request, anytime that any of the machine makes a HTTP request, they should get a pop-up. They should get a pop-up that you are not allowed to build this. Okay. So very simple thing. Whenever someone is trying to get or make a HTTP request over the browser, they should get a pop-up that you are not allowed to use this. Okay. I created this particular function, right? I created this particular function using your Microsoft Azure functions, and I deployed this particular thing over all the machines that I am using, right? Now, as soon as any particular person who is operating this particular machine opens its browser and makes a HTTP request, right? He will get a pop-up that you are not allowed to do this, irrespective of the environment, right? I can write code in any language. I can write code in your C hash, Java, PHP, JavaScript, right? Any language I can write code, right? So this particular function have multiple templates. We can say it will have multiple templates with it. So according to your choice, what template you want to choose, you can select that thing and you can deploy this particular function over your Azure network. Okay. Now this was about your container technology part, right? Now we'll be talking about your Azure, right? What are your architectural components in Azure? What basically Azure is, how the portal of Azure looks like, right? And how we can like learn to create your machines over your Azure, right? These all things we will learn. So simple thing, go to your browser, open your Simply Google search Azure portal, you will get to that particular thing, right? So simple things. I'm over the Google. I'm simply searching for Azure portal. I click on this particular first link, portal.azure.com, right? So you can create your own account, right? So I created a new account for this particular thing, Microsoft Azure. This is the account. I will log in. Simple thing. Anyone can create state sign in. Okay, right. This is how your Azure portal looks like. Optimize your cloud workload groups. Okay, see recommendation. Like so, this thing we can do. For now, we will go with the basic ones. Right. So as soon as a new user logs in into your Azure portal, you will get three options. Start with Azure free trial, manage your Azure ready, access student benefits, right? So since we are at a learning phase, we will go with the free trial, right? So in this particular free trial, you will get around $200 credit with your Azure products and services, right? So it is basically a 1 month subscription. Over that particular thing, you will get around $200 credit in your Azure account, right? So you can use this particular $200 to use different resources that are available in your Azure portal, right? So we have your SQL database, we can manage your subscription, your virtual machines, quick start center, app services, right? We can navigate, we have different tools for your Azure monitor, security center, cost management. Yesterday I told you that we have cost calculators for different cloud service providers, right? Each service provider have different pre-built calculator in it, so that you can manage the cost of the resources that you are using, right? So simply click on this particular thing, start your free trial, right? So that you can get a $200 credit, and because of this $200 credit, we can use different resources, right? Because each resource will be the paid one, so we can use that particular resource through this particular credit, right? You can even personalize your own portal, right? You can change this particular portal, you can customize it according to you, according to your need. Here when I right clicked on this particular thing, you will see different options that are present over this particular dashboard, right? So we have our own dashboard. We can go and look at what all services are there in your Azure. We can scale our services by adding or removing the subscription according to your business needs. We can monitor the health of any application that we purchase or that we are using in this particular portal. We can create a report that what is the users of any resource that we are using at what particular time. So let's just say I'm using 5 resources at a single time, right? So I can create an analytical report that how much I'm using that particular application, whether there is a need or not, right? All these things I can do. I can also analyze the performance of any application that I am running through this particular portal, so that I will get a good idea that whether the users who are using my application is facing any problem or not, right? All these things we can do. So basically, this is you can say like your virtual infrastructure, right? All the things are available here, right? Let's talk about the services which we can use through this particular portal, right? So what are different services which we get through this particular Azure portal? First is your compute, your computing part. In this compute, we have your VMwares, right? Virtual machines. We can create a set also of this particular machine that if we have 4 departments in our organization, So what we can do for the four departments, I can set different virtual machines, three for one department, four for one department. Like this, I can create a set. In your compute also, we will be talking about your Kubernetes. Your Kubernetes service will be also under your compute part only. Then your batch management, container instances, if you are using any container, your functions, all this will be under your compute part only, right? So this is the first factor, or we can say this is the first service which is there in your Azure, right? The second one is your networking part, right? Because your Azure portal is nothing but your infrastructure, your virtual infrastructure, right? So whatever we do in real time, we all get uh, Azure have different storage for the users, right? It has its own storage also, your Cosmos DB. This is the storage which is created at your Azure portal itself, right? Other than this, we have different storage sectors which we use in our day-to-day life, right? We can all use those things in your Azure portal itself. We have services for your mobile also. If someone wants to create a service for your Android, iOS, or your Windows application, right? They can do that particular thing at this particular portal because it also provides your platform as a service, right? It will provide you a platform to create or deploy a machine, your mobile application over this particular Azure portal itself. Then we can use different web application service also. Multiple web application services are there with your Azure. Your IoT services are also there. ML, your ML and AI services, right? Famous one for your Azure is your IoT Edge, right? So any service which we use in our physical premises, all the service are available in this particular portal, the Azure portal, right? We have a marketplace of different resources, right? So even you can use third party resources at that particular marketplace, right? You can even create your own application and deploy it over the Azure portal, right? Your third party application, right? And someone can use that particular thing over that particular portal, right? Whatever do we do on premises, everything is available on this particular thing. Then few of the basic components we talk about regarding your Azure are your regions. These are the places where your Azure data centers are placed, right? So your data centers have been placed at different regions. Azure offers more global regions than any other cloud providers, with 60 plus regions representing over 140 countries, right? So if we talk about like in today's scenario, Azure have the most number of regions or the most number of data sets, data centers to give to the users, right? And it is spread over 140 countries, right? So globally it is available to anyone who want to use this particular service. Each country will have different compliance rule. So each region, according to the country, it will have the compliance rule which is set by the government of that particular country, right? So if you want to set a data center according to the compliance rule over the England or over the India, you can do that thing also. Now region pairs, right? Yesterday we talked about your disaster management, right? That how using your cloud we can do the disaster recovery, right? Each Azure region is paired with another region, right? And Azure prefers at least 300 miles of separation between data center in a regional pair. So what is happening here? This is your one data center. This is your second data center, right? When you create an account on Azure, right, you are assigned this particular data center, right? So whatever resources you are using, right, whatever things that you are doing, it will be stored at this particular data center, and the copy of this will be moved to this particular thing, right? So that in case of any disaster, when this data center is not working or this data center is down, your services don't stop. You can still use this particular Azure from this particular data center using the same resources that you were using or which you deployed at this particular data center, right? So this is why your Azure always have your region pairs, so that in case of any disaster, your services does not stop at this particular Azure. This thing is also used like for your updates. If the hardwares that are present at this particular data center, if they want to update this particular thing, right, so they can shift your services to this data center, so that they can do updates on all these hardware parts, right? So that again you are up to date with the market. Now we talk about your availability zones, right? So we have your single virtual machine. Your availability set is nothing but the combination of your different virtual machines that you are using. And availability zone, it provides protection against downtime due to data center failure, right? So what this particular zone will do, it will separate your data centers within the same region. If two data centers are there at this same particular region, right, we have two data centers at this s- same region. With the help of your availability zone, we can separate these two things, right? So in case of one data center failure, it should not affect the second one, right? Because each and every data center is like either connected to your private fiber optics networks, right? That is why. So if one data center is facing the problem, it should be made sure that second one is not facing that particular problem. When we talk about your virtual machine, right, here we have like SLA agreement of around 99.9%. It will be available to you around 99.9%. If you are using this particular set, your multiple machines, they will be available around 99.99%. These things are already mentioned in your SLA, your service level agreement, when you join your Azure portal, when you start using the resources, right? And over here, right? So this thing is why we are getting a zero point 0.1 difference because of fault tolerance. If this thing is down, we have to wait for the another machine to start and load this thing, right? Here, why we are getting only 0.1%? Because 0.01%, because we have divided or we have separated different data centers into different zones. Even if one stops, we can continue the service with the other one, right? So that is why the fault tolerance here is just 0.01%, but in case of your single virtual machine, it will be around 0.1%. Okay, so best example, if the application, your VMware application on my particular device stops, the chances are there that I have to wait to like update that particular application, or I have to do I have to check for faults that why it is not working, like that only, right? But if I'm using your Azure VMware, it will automatically be shifted to new data center, so that my services never stop. Whatever services I'm using, it should never stop. Availability zone again, each zone within Azure region is essentially a separate data center. Each zone has independent power source, networking, and cooling, right? Because I said each zone is connected through private fiber optic networks, right? That is why each zone will have different power source, your different networking cables, and different cooling structures, right? And any other things which we have. Each Azure region with availability zone made available will have at minimum three separate zones, right? So these are some basic functionality of availability zones which are available in your Azure. Resource group is a container to manage and aggregate resources in a single unit. This particular thing act as your manager. Your manager will manage all the employees working under him, right? So this resource group will manage all the machines, all the resources that I am running, right? I can create multiple resource group, one for my HR team, one for my accounts team, one for my IT team, right? And whatever is happening under this HR team, the HR head will maintain that thing, the account head will maintain the things which are happening under this particular thing, and same what is happening under the IT team, it will be managed by the head of IT team, right? So what I did as a CEO, I created different groups, right? And why? So that the functionality does not change with each other, right? Resources can be moved to different resource group, right? So if I found that okay, we have two IT departments, right? Let's just say this is IT department 1, this is IT department 2. If someone is working on the same project that this IT team is working, or if the manager finds that this person is needed at this particular department, right? He can contribute here more than this particular department. So you can shift this person to this particular department also, right? Similarly, you can shift this particular machine, whatever machine you are using in this particular department or this particular resource group, to any resource group that is present under your Azure subscription, right? If you have created four resource group, any machine, any resource that you are using in any of that particular resource can be shifted to other resource groups. Applications can utilize multiple resource groups. Again, your best example of your Azure functions. I can deploy this particular function in each resource group, right, at a single time. I don't have to like deploy it at a single machine. Simply over this particular resource group, I can deploy this function. As soon as I deploy this function, this function will act on all the devices, all the resources which are working under this particular resource group. So in your Azure resources, we have your VMwares, your storage accounts, your virtual networks, your functions, SQL database, app services, your IoTs, right? Your DevOps, right? Different things which we discussed. All these things are present under your Azure resources. So Azure resources are components like your storage, virtual machines, and networks that are available to build cloud solutions, right? So if you are like building a particular application or software over the cloud, you can use these resources to build that particular thing. Azure subscription, right? So right now I showed you like we have different subscriptions. So what I can do, like if I want to start a company or an organization, one will be my main account, right? Under that thing, I can buy different subscription, right? For different teams, right? So let's just say I want to give 5 resources to my HR team. So I will buy this particular subscription and I will give this to my HR team. Okay. If I want to like same goes, if I want to give 7 resources, like if I want to purchase 7 resources for the DevOps team or your developer teams, I will purchase that thing and I will set that particular thing right here. Right. Similarly, you will have one main Azure account. Under that account, you can create multiple subscriptions. right? One can be for your developer, one is for your testing team, one is for your production team, right? And you can allocate different resources under this particular subscription. That okay, the developer team will have a budget of around, let's just say, $1,000, right? So they have to manage those resources according to this particular $1,000 only. The budget of your test team is around $500, so they have to manage, right? They have to manage all the resources under this particular thing. Similar, this is what your Azure subscription is, right? You can create different subscription for different teams according to your need. And this particular, the main user will have all the information that what resource is being used by which particular team, right? How you are utilizing your 1000, how you are utilizing your $500, right? Like this. Azure Compute Service, we already discussed. Like here, we can get your VMwares, your application service, your container instance, your Kubernetes. In case of Azure, your Azure Kubernetes service. You can also use your third-party services with respect to your Azure computing part. You can also use your third-party services. You can host your servers, your Windows virtual desktops, all these things, all your computer things can be done under this particular part. Azure virtual machines. So it is very similar to your normal virtual machines. Only thing is they are utilizing the resources of the data center created by Azure. Virtual machines let you create and use VMs in the cloud, providing what is known as infrastructure as a service. Same thing. If I'm using virtual machine in my laptop, it means that I am consuming my resources, right? But if I'm using Azure virtual machines, so it means I'm consuming the resources which is provided by Azure data center, right? So they have your infrastructure as a service, and over there I will be using my virtual machines. Azure App Service again. Azure Web App is a compute resource that provides a fully managed platform which is optimized for hosting websites and web applications, right? So when we were creating the Tinder, when we were creating the Tinder application for ourselves, right? We can simply host this particular application over your Azure App Service because you can see it supports many programming languages. Your ASP.NET, your Node.js, Java, PHP, Python programming, right? It supports multiple languages, right? So it will be very easy for me to create your container images for this particular application. And since it have your Docker, Azure Docker, it will have your Kubernetes, Azure Kubernetes Service AKS. It will be very easy for me to manage this complete application over this particular Azure platform, right? Because it have all these particular things with me. Container service, we discussed what container is, right? Same thing. So it is Azure is also having a container service. You can create multiple images of different applications or software using this particular Azure part. Networking part, we have your virtual networks, your VPNs, your Azure Express router, right? So these are the things which helps you in your networking sector when we talk about your Azure portal. Storage, we have your blob, your disk storage, your Azure files, right? So that this particular thing is basically used to store your data or for your backups. So again, according to your need, you can use any of the service which is provided by your Azure, right? So similarly, like this only, there are multiple services. So if you look at the portal, right? So these are the Azure services which are here. If you want to search for marketplace, right? So here is the marketplace. Here you will see all the services and resources which are available with your Azure. Okay, so categories are also here: AI and ML learning, analytics, blockchain, compute, database, developer tools, DevOps. All the category is here at your marketplace. It is like your real-time market, right? You can purchase any service. Software plans start at free, right? So you can see that there are some Azure services. You will also find your third-party services which people offer over this particular Azure portal, right? So according to your organization need, according to your need, you can use any of this particular service. Simple thing is you have to simply create a subscription pack so that, like, again, you don't exceed a particular amount, right? It will, once your like $200 credit which you are getting is completed, right, or is like you are using more than that, right, you will get a notification for sure that okay, your $200 limit has exceeded. If you wish to continue it like this, you will get some notification, and that particular $200 is also available for like around 1 month only, right? So for a month you can use different services. We have like very good options here that once we start a service, if we don't want to use, we can stop, so that we don't have to pay for that particular thing, right? So tomorrow we will see that how we can deploy a particular VMware, right? How we can use the services which are present, how we can deploy a virtual machine, how we can deploy a server, right? How we can use your Azure functions, right? All these things we will learn tomorrow. So for today, like, take your Azure subscription, the free one. Simple. Once you start this thing, you will get a $200 credit, which will help you to use the services provided by your Azure portal.